Alright, so you have your notes, and in example number 1 it says, I believe 60% of the marathon runners are men, and you believe that that number is too high. At the 5% level, let's decide who's correct. So, if I was in class, I'd pass out the sticks, and let's just say that we had 50, and of those 50, 28 were male. So, what we're going to start out doing is we're going to start out with our proportion. So P, not P hat, but P is equal to the proportion of marathon runners who are male. And we are doing what is called a Z proportion hypothesis test. And once we know this, if I was in class and we did this, it would be an SRS because of the way we gathered the sample. And independence, 50 times 10 equals 500, which is less than the total number of people. Oh, and I forgot to do something at the very top, but let's do the normality first, and then we will... Actually, I have to go back and change something, because we didn't put the hypothesis on here. So, we need to say that alpha is equal to 0.05, and the initial hypothesis is mine, which is that the runners are at 60%, so P is equal to 0.6, where yours is P is less than 0.6. So for normality, we're doing 50 times 0.6 and 50 times 1 minus 0.6, because we're using n times what we assume P to be, because in all hypothesis tests, we assume that the null hypothesis is true. So 50 times 0.6 is 30, 50 times 1 minus 0.6 is 20, and both of these are bigger than 10, so we get something that is approximately normal. Calculations. Here I got P is equal to 0.6. My standard deviation is going to equal 0.6 times 0.4 divided by 50, that's n times P. And somewhere over here is P hat, and P hat, which was 28 out of 50, is 0.56. So P hat equals 0.56, and we're trying to figure out this part. So the best thing for me to do is to find out what Z is. That's 0.56. So Z equals 0.56 minus 0.6 divided by 0.6 times 0.4 over 50. So that gave me a Z-score of negative 0.577. So what is the probability? So this is finding the p-value. What's the probability that Z is less than negative 0.577? So I'm going to use my normal CDF from negative infinity to negative 0.577 with a mean of 0 and a standard deviation of 1, because we made a Z-score. And that gives me 0.28. which is greater than 0.05. So the last part is the conclusion, which starts with either I reject the null hypothesis or I fail to reject the null hypothesis. So for this one, I'm going to say I fail to reject the null hypothesis. I do not have enough evidence to show that the percentage of marathon runners who are male is not %60. So I'm not saying that the first one is true. All I'm saying is that I don't have evidence to say it's not true. So we will do this again with problem number 2. Okay, for problem number 2, this time we're talking about 12% believe that Congress is doing a good job. So in this case, P is going to equal the proportion of people who believe Congress is doing a good job. And so this time they want to have the initial hypothesis is they believe 12%, and the alternate hypothesis is different, so we're going to say P is not equal to 12%. And they didn't tell us what alpha was in this problem, so I'm going to continue to make alpha equal to 0.05. That's the one that's most commonly used, and we are having a Z proportion hypothesis test. SRS. Doesn't state it, but it should have. Independence. We got 2,000 times 10 is 20,000, which is less than people. Probably should have said it in Americans, but normality. 2,000 times 0.12, there should be decimal points up here, and 2,000 times 1 minus 0.12, and that is 240 and 1760, which are both bigger than 10. And in the test the other day, people were mixing up the independence and normality as well. That was another mistake that kept happening. Normality is the N times P, and the independence is having a population bigger than 10 times. So let's do we need P hat. In order to get P hat, we go back to the question. P hat said that 204 out of 2,000. So P hat is 204 over 2,000, which is 0.102. Here's P equals 0.12, or mu of P, I should say. Should have said that in the last one too. My picture. This is mu of P. And sigma of P hat. is the square root of 0.12 times 0.88 over 2,000. .102 is here, and we're going to shade in this portion, and we're going to shade in this portion. So let's find the z-score for 0.0102. And I get the answer of negative 2.47. So I need the probability that z is less than negative 2.47 or that z is greater than 2.47. So I'm going to do the normal CDF from negative infinity, so from negative, in our particular case, negative 99999 to negative 2.47 with a mean of 0 and a standard deviation of 1, and then I'm going to multiply that by 2. And don't forget to multiply by 2, and so it turned out to be 0.013. Since this is less than 0.05, this time I reject the null hypothesis. I have evidence to suggest that the proportion or percentage of people who think Congress is doing a good job is different from 12%. And that's pretty much how we do the proportions. Alright, start working on your homework. If you have questions, I'll be in tomorrow.